Hello everyone, I am Jun Park, who is machine learning research scientist in Orchestra. This time I would like to presentation about cost optimization strategy for private cloud with machine learning based workload prediction. In recent years, cloud adoption has accelerated across various sectors, driven by digital transformation or cloud-native development or some AI research or service delivery. So organizations typically expect benefits such as a low operation cost or efficient resource management or stable resource environment, but actually it's not much. It's kind of very strict. Sometimes it's very some case the cost is more increased compared with on-premise environment. The private cloud is much more. This is the importance of cloud cost optimization, which help organization better configure their resource and remove wasted expense to achieve their initial cloud adoption goals. It means more cost effective and stable and more easy to use. I think you probably heard about cost optimization before. However, most people familiar with about cost optimization for private cloud, like AWS or GCP, but not for private cloud. The approach of these two type cloud is very different. So in private cloud, cost optimization can be achieved through the visible method like reduce virtual machines, reduce number of virtual machines, or resize virtual machines, or remove unnecessary public IPs, this kind of thing. But private cloud is not offer this kind of flexibility. As you know, the private cloud does not make immediately reduce server's number and strategy, but and then additionally cost factors such as some colocation cost or electricity cost is charged even though public cloud is not. But this kind of cost factor is very important cost factor in private cloud. This is total cost of ownership in private cloud, which increase ongoing equipment and contract expense, while challenging immediately cost saving. Public cloud have a meaning advantage in regard due to their pay-as-you-go billing structure, but allowing this immediately application cost saving measure. So this question is coming out. Is it impossible to optimize the TCO of private cloud? So my answer is not. Total cost of ownership also can be optimized, I think. So then how we can do this? How can we optimize the cost of TCO? There is several factors in private cloud that can be reduced by managing resource usage from the same perspective as private cloud. It means this kind of power usage of servers, purchasing price of servers, and vendors use of network is managed. This can reduce it by managing resource usage, and it directly connected to risk cost reduction of the private cloud TCO. It means I would like to explain about this more detailedly. Step by step. First, the power usage of servers is highly dependent on computing source utilization, including VM utilization, contents utilization, or load utilization. Higher workload lead to high power consumption, and it consequently lead to higher cost. Second, server purchase price is determined by server's specification and replacement cycle. So higher computing power means required more high specification servers, and it means we need to much expensive server. And some inefficiency replacement cycle of power, physical servers, it may more wasted expenses also. Last, the network bandwidth usage is correlated to maximum network bandwidth usage and contract traffic capacity. And if this kind of things potential additionally charges for exceeding the limits. So private cloud like public cloud have a pay-as-you-go component in their TCO. This kind of cost factor means it can connect to the pay-as-you-go billing structure like public cloud. This allows the applications of linear cost optimization methodology. For example, first for server usage optimization, organization can size allocate a resource to match workload requirements, clearly separate idle and active resource, and we can apply the power saving policies to idle resource. To reduce server purchase price, organization can define the workload characteristic and size as benchmark. Purchase equivalent meeting criteria at the purchase this kind of criteria, and purchase equivalent and establish equivalent lifespan with a regular cycle. Network bandwidth usage can be reduced by implementing throttling for non-core application or during idle time, and allocating bandwidth based on application priority. This means actually this kind of thing is not much immediately cost reduction methodology like public cloud, but it have that much powers. It have this much effective. So I would like to focus on this kind of cost optimization methodology for workload prediction, workload forecasting. While this strategy is very simple in principle and can yield quick result, it's crucial to apply them with careful consideration for preferred criteria. Aggressive resource reduction can improve efficiency and cut cost heavy workload, but it means also increase the risk of failure under heavy workload. Historical performance metric was determined in existing way to setting this baseline for how much we can optimize with avoiding failure. They alone are not enough stable as they don't account for future change. This is where workload forecasting becomes essential. Forecasting allows organization to expect future trend and pattern, formulate optimization strategy, and threshold based on prediction workload, and test impact of interdependence between different application or system components in post optimization. Workload prediction serves as a crucial foundation for identifying optimization method that increase efficiency while minimizing reduction in site reliability. This is very important thing. Now that we know what cost optimization in private cloud is and why workload forecasting is important here, let's take a look at how you can use it. Two popular machine learning based on forecasting techniques are ARIMA and Prophet. These models are widely used due to their simple structure, lightweight, and good forecasting performance. Actually, who can think where is the deep learning models like transformer or LSTM? Actually, that is show very good forecasting performance and we can say it is state of art, but actually in production environment, the available resource is limited. So, high number of CPU core or GPU resource is very limited in production environment. So this ARIMA and Prophet is showing enough performance in limited resource, but very preferred. This is a big reason in why this kind of ARIMA and Prophet is implemented in real production environments. So first, ARIMA consists of these three integrated functions: auto regress, which predict future data based on previous data; moving average, which reduces prediction error; and differencing. I mean is differencing. So ARIMA is AR, auto-regressive, integrated, moving average. The ARIMA model predicts future value based on weighted combination of previous data points. As described in its formula, ARIMA multiply recent historical data by weight and add prediction errors and then the deviation to driven up forecast. During the training process, this weight continuously adjusting to minimize difference between actual future value and forecast future value. So while simple in structure, what ARIMA requires careful parameter tuning and struggling with complex trend. I say the ARIMA is show enough forecasting performance, but this is limitation. Complex trend change is a weakness of the ARIMA. So if you have if your workload is very complex, you have to use different machine learning model. So Prophet beside Prophet developed by Meta consists of 4 components: trend factor and seasonality component, holiday component, error count. This is other side. This is standing other side of ARIMA. So I would like to explain about more detail about Prophet. The Prophet fit multi-cover to identify trend. To identify trend. Use Fourier transform to detect seasonality and incorporate the holiday effect and forecasting error. As shown in the right figure, the Prophet fitted with this left figure show identify this kind of trend moving some majority flow like this, and also indicate to detect the seasonality in this is weekday and weekend. So this is how work Prophet is and how they can forecast the from given data to future workload. In addition, the Prophet consider the evolution of trend over time with when forecast the trend, showing very good forecasting performance. So this red line is the Prophet detecting now this kind of period have a trend changing now. So and then by the principle of the Prophet, the Prophet have a robust missing data and outliers and handle complex trend change more effectively. But Prophet may abstract complex pattern to simple one by their mechanism. I already said about how the Prophet detects the trend. They fitting multiple cover of with given data. So even the given pattern of the data is too complex, the Prophet can make it too simply. So it means the Prophet is not much showing good accuracy in that kind of case. So in my experience, the most of cases are even showing enough forecasting performance in workload prediction. As you know, this kind of ARIMA or ProPay can utilize in a lot of fields, not only workload prediction, but in workload prediction field, I think ARIMA is also showing very enough performance, even though use the ProPay. But this is the consideration of based on your workload data. So forecasting provides valuable insights for applying optimization techniques such as right sizing. By predicting future work peak and idle period, organization can properly resize VM or containers and decline resource idle during idle time, and increasing overall cloud system efficiency. This approach allowing minimizing idle resource, potentially saving or on electricity cost by powering down server or rack when possible. It means if we collect the idle resource by resizing or reclaiming the idle resource, and if we can make some empty VM server or empty VM serverlet, we can powering down them. Then we can save the power. We can power consumption is needed, and it can also assist in anomaly detection by identifying potential failure to the comparison of prediction and actual workload, and supporting continuous improvement by enabling ongoing monitoring and assessment of the optimization effort. This is one of example in AWS anomaly detection. This violet line is forecasting and the red point is out of the forecasting. So when we see this kind of thing is some strange, or this kind of thing is not expected for us, we can check and investigate about this, and we can reduce if they make some unnecessary cost, we can save it also. Finally, actually, we are expecting the workload prediction is always correct in future forecasting, but it is not. The machine learning model have a weakness. Is not always showing always accurate output. So we have to consider it. We have to remember and recheck the output of the machine learning model's prediction. This is what kind of thing we have to consideration, and what kind of we have to do to implementing this kind of machine learning based workload forecasting of course optimization. First is machine learning based prediction may be less accurate for extreme events, not reflected in historical data. It is very opposite. Actually, the machine learning model also training based on the previous data. So even some extreme event is not showing in previous data, machine learning models cannot also forecasting that. So this means if relying only on the machine learning based forecasting and reduce the resource too much, it can lead to some failure, or even something normal workload spike. This is so. I would like to say if you optimize the resource or declining idle resource, you have to make some headroom for even something normal workload spike coming out. It is okay. And additionally, the pre-optimization prediction of the machine learning model is coming out from current current system configuration and high availability configuration. It means if you change this kind of configuration after the optimization, the forecasting value cannot guarantee about post optimization environment. So you have to recheck if this current optimized environment is trustable and the forecasting is correct or not. Also, and finally, any cost optimization strategy have an improvement room. So continuously monitoring and assessment to take assessment to this cost optimization is enough, or is it have any problem for our environments? So even if they have some problem or improvement point, we have to take about that and enhance and adjust the setting to better suit your involving environments. This is end of my presentation. Thank you for your attention. If you have any question, please feel free to ask.